So the first thing I'd like to do is graph each of the following functions. Graph each function. We'll say on the interval -2 pi to 2 pi. So we're going to graph the 6 trigonometric ratios from -2 pi all the way to 2 pi. So I've given you a piece of graph paper. I'm going to go up by quarter pies here. So this would be pi over 2, pi, 3 pi over 2, and 2 pi. And on the other side, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. We'll go up to 1, down to -1. So again, I'm going to go through this fairly quickly, and then
Good morning, Westbound. Sorry for the interruption to class. If I could have the attention of all staff and students. On Monday, we did read a warning of an incident that happened in our neighborhood where a 17-year-old girl was approached by a car. On Tuesday morning at 8:30.
okay. So continuing on, we are going to graph the sine curve. Now in your guide has a whole bunch of points in order for you to graph the sine curve. Okay? What I'm going to expect you to remember are the 5 critical points of sine. Okay? Now again, I'm going to go over it quickly because we graphed the sine curve in grade 11. The sine curves starts at 0 and 0. Then the next critical point of sine, so it starts to head up to its maximum point, and that occurs at pi over 2. And then it heads down to pi and 0. And then heads right down to its minimum value, which occurs at 3 pi over 2, and that's a value of -1, and then heads back up to 2 pi. So it's going to be very, very, very important that you remember these 5 critical points for sine. So starting at 0, and there's always a pattern to trigonometric ratios when you're graphing them. So for the domain, you're going up by half pi's, so pi over 2, 2 pi over 2, which is pi, 3 pi over 2, and 4 pi over 2, which simplifies down to 2 pi. It starts in its middle value and then heads up to its maximum, then down to its middle, then down to its lowest, then down to back up to its middle value. So if I connect these 5 critical points, what I'm producing is the primary graph of the sine curve. So again, it's a curve, so don't use a ruler. Use freehand to try to draw it as fast as you can. So this is the primary graph of the sine curve. It starts at 0 and it finishes off at 2 pi. So the period is 2 pi. So that's the length it takes to complete its primary cycle. And we learned last year, right, so there shouldn't be anything new. The only thing new is that we're labeling the bottom in radians instead of degrees. And you learned last year that sine and all trigonometric ratios are periodic, which means they continue off in each direction forever and ever. Okay? So what I'm going to do is I'm going to use this pattern to continue on my sine curve. So if you see, to get from one point to the other, I go over 2 spaces up 4, over 2 down 4, over 2 down 4. I can continue that pattern to draw the rest of the sine curve over to -2 pi. So over 2 down 4, over 2 up 4, over 2 up 4, over 2 down 4. That's a very important skill because we're going to be using that skill when we get into the transformations of the sine curve. Okay, so that is the complete sine curve all the way from negative 2 pi all the way over to 2 pi. So the domain of the sine curve is x is an element of a real number, but in this case I told you to graph it between negative 2 pi and 2 pi. The range of the sine curve, the range of the sine curve, the highest the sine curve ever gets is 1. The lowest it ever gets is negative 1. So y is always between negative 1 and 1. And it has to be a real number. Okay. So to produce the sine curve, really what you want to do, remember, is these 5 points right here. And you would quickly graph those 5 points and connect them up. On Monday, we're just going to be putting those points through transformations. Okay, so very important that you understand these points. Any questions on the sine curve? Okay. The cosine curve. Again, we're going to graph it from negative 2 pi to 2 pi. So I'm going to label my axes. Okay, so the cosine curve. The cosine curve really is just a transformation of the sine curve. Okay? It's the sine curve moved over. So what you need to remember for the cosine curve is it starts at 1. But then it continues on the exact same pattern that the sine curve does. Okay? So over 2 down 4, over 2 down 4, over 2 up 4. And when we connect these 5 points, we get the primary graph of the cosine curve. So it's going to be very important that we remember those 5 points for the cosine curve. But again, right, it follows the same pattern. The domain is going up by half pi's. And the range oscillates between 1 and negative 1, starting at 1, down to 0, down to negative 1, back up to 0, back up to 1. Right, so those are the 5 critical points of cosine. Very important to remember. Okay? We're going to be putting the sine and the cosine curve through transformation. But also we're going to be using the sine and the cosine curve to draw the other functions. Okay? Since I was asked to draw it from negative 2 pi to 2 pi, I want to continue on. And again, I'm just using the pattern because it's periodic in order to draw the rest of it. Right, just like the cosine curve, the period, just like the sine curve, the period of the cosine curve is 2 pi. The domain is x is an element of the real numbers, but in this case we restricted the domain between negative 2 pi and 2 pi. And because it's just a transformation of the sine curve, the range is going to be the same. So y are numbers between 1 and negative 1, and y is an element of the real numbers. So it's very important to reproduce these, being able to reproduce these functions. Again, in your guide, they have you do a whole bunch of points. The most important thing is to be able to do the 5 critical points. Okay? You plot those 5 critical points, join up, you get the primary graph, and you can just continue on. Any questions on that? David, do you have a question? Oh, this right here? So x is an element of real numbers, and then x is between negative 2 pi and 2 pi. Okay? And again, that's part is just because they said that in the question to draw it between those guys, because that could change in the question. Any questions on this? Okay, we are going to use all the information that we know about the sine curve and the cosine curve to draw the other 4 trigonometric functions. We're also going to need to use our calculator. So if you guys can grab out your calculator and make sure that it's in radians. Okay, so your calculator display should say RAD or R on it. Okay, it usually says DEG or D on it. So we are going to use what we know about the cosines and the sine curve to graph the cosecant. The cosecant is the reciprocal of which function? Does anybody remember? Okay. So the cosecant is the reciprocal of the sine function. So the information we know about the sine function, when I take 1 divided by sine, I'm going to get a cosine value. Okay? So again, we're going to graph it between 2 pi and negative 2 pi. Okay, so what we're going to do is we're going to draw the first one together. We're going to have to use our calculator at some point just to help us get what the graph looks like initially. And then once we know that, we're going to be able to reproduce it a little bit quicker because we're going to have a generalization of what the graph looks like. So the cosecant is 1 over the sine. So I'm going to use the sine curve in order to help me graph. So whenever the sine is 0, so the sine is 0 here, 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 and here, when I take 0 and plug it in here, what's 1 divided by 0? Sure? Does not exist. So when it doesn't exist, you're going to get a vertical asymptote. So everywhere that the sine is 0, you are going to get a vertical asymptote for the cosecant. So the first thing you're going to do is draw in your vertical asymptotes. And again, you're drawing them whenever sine is 0 because you cannot divide by 0. And remember, the cosecant is the reciprocal of the sine. So I draw in my asymptotes. Going back to the sine curve, over here, sine curve. Whenever sine is equal to 1, which is at negative 3 pi over 2 and pi over 2, so when sine is equal to 1, what would the cosecant be equal to? So whenever sine is 1, if I plug 1 in for sine, what's the value of the cosecant going to be? Okay, so wherever sine was 1, the cosecant is going to be equal to 1. So here and here. Wherever sine was equal to negative 1, what's the value going to be? Negative 1. So sine is negative 1 here and here. So this is the information that I can glean from the sine curve to help me draw the cosecant. Okay? But this is all you're going to be able to, this is all you're going to need in the future to draw once we get a generalization of what the graph looks like. Like I was saying, the hard part in this unit for most people isn't the grade 12 math, it's like the grade 3, 4 fractions. Okay? It really is. So get to use your fraction calculator, and if you're really struggling with it, don't be afraid to ask me. Okay? So we're going to use our calculators now to figure out some values just until we get to generalize how the graph looks like, and then we won't have to do this again. So between 0 and pi over 2, what's this value right here? Yeah, pi over 4. Awesome. Okay. So in your calculator, figure out what the cosecant of pi over 4 is. So your calculator is in radians. You don't have a cosecant button, so depending how your calculator works, you would type in 1 divided by the sine of pi over 4. Some people would have to go pi over 4 sine and then divide it by 1. And then get that answer and take that answer and take 1 and divide it by it. Some people would be able to go 1 divided by, then put in pi over 4, then sine, then it equals. Figure out how your calculator works, because everybody's is different. Did anybody get a value though for better? 1.4, perfect. So here's 1.5. Okay. So this was pi over 4. What's halfway between 0 and pi over 4? Pi over 8. So tell me what the cosecant of pi over 8 is. Yeah. 2.6. Right, 2.6. So that's going to be up here. And then, indeed, what happens is the closer you get to the asymptote, the further and the higher the numbers get. So this starts to head up, and it goes towards positive infinity. And it starts to get closer and closer to the asymptote, but it never crosses. On the other side, it's going to do the exact same thing. And you can test that with some values if you want, if you don't believe me, and it'll do that. What do you think is going to happen over here? Bert? Exactly. The exact same thing. So that right there is the primary graph of the cosecant. So the period starts at 0, ends its primary cycle at pi over 2. So the period is, not pi over 2, is 2 pi. And then it just continues on like that forever. So now that we know what the graph of the cosecant looks like, when you're doing it on a test, and you will be asked to, okay, use the sine curve. Draw on the asymptotes, draw on when sine is 1, draw on its negative 1, and then draw your little parabola looking guys. Any questions on that? Okay, so you'll also be asked to state the domain and the range. And I would say most people on the test lose marks on this. Okay? So the domain of this function is x is an element of the real numbers, but x cannot be equal to the places where it has asymptotes. Okay, so you just list them. Negative 2 pi, negative pi, 0, pi, and 2 pi. So I've listed them as 0, plus and minus pi, plus and minus. And then the range is y is an element of the real numbers, but the lowest y ever gets is 1. So y is always greater than and equal to 1, and y is always less than and equal to negative 1. Any questions on that? Okay. So now that we have a generalization of what these graphs look like, to graph the secant, right, it should take you less time in order to do it. So remember the secant? Yeah, sorry. Yeah. Yep. I mean sine to the 1. It's where it's equal to 1, right? So if I go back over here, right, at negative 3 pi over 2, the value of sine is 1. So I'm taking that value 1 and placing it into here. So it becomes 1 divided by 1. And that's where I get that right there. Does that make sense? Yeah, you're not taking 1 and taking the sine of it. Okay. Okay, so if I ask you to graph the secant, and depending on which version of the test you get, you will be asked to do this. You have to remember that the secant is the reciprocal of the cosine. So you label your axes. Yeah. Okay. No, someone's flying with this one here. I don't know. I'm not sure where it is. Okay. So again, very quickly, and again, I'm not marking on speed, but it shouldn't take a lot of time is what I'm trying to tell you. Wherever the cosine is equal to 0, so you remember your cosine curve, this is it right here. Wherever it's equal to 0, that's where you're going to get asymptotes. So the cosine is equal to 0 here, and here, here, and here. Wherever the cosine is equal to 1, the reciprocal is going to be equal to 1. So cosine is equal to 1 here, here, and here. And wherever cosine is equal to negative 1, down here and here, the reciprocal is going to be equal to negative 1. Since the cosine is a transformation of the sine, then the secant is a transformation of the cosecant, and we know what that graph looks like, so we can just draw in the rest of the secant graph using the prior knowledge we had. So this, I'm just drawing that one branch of it because I'm not going beyond 2 pi. So the period is 2 pi, right? Because it takes here and here to complete its primary cycle. The domain is x is an element of the real numbers, but x cannot be equal to the places where it has asymptotes, which was positive and negative pi over 2, and positive and negative 3 pi over 2. The range is y is an element of the real numbers, y is greater than or equal to 1, y is less than or equal to negative 1. For some reason, the domain and the range are the most, are the questions answered most incorrectly in the test. Does this part make sense, what I'm doing? Is that clear what I'm doing here and here? Okay.
You're basically just showing what we already know from our previous graph, right?
Yeah.
The domain and range.
Right, exactly. But here, and then here you're just reading it off, right? Like the domain's everything except for the green lines. You just list them, right? And the range is always bigger than 1 because there's nothing in between here, and then it's always less than negative. That's how you do it, is reading off the graph and listing it. But for some reason, I would say about 50% of people get these questions wrong. So I just want to come back to that. Are we okay with the domain and range? Okay. And so it shouldn't take you a lot of effort to reproduce the secant. So let's just do one more. I wanted to do what we know about the sine curve and the cosine curve to draw the tangent. So again, I'm just going to set up my axes one final time. And again, for the tangent curve, we're just going to need to use our calculator to get some additional points to help us get the general graph of the function. And then once we learn what it looks like, then we can reproduce it fairly quickly once we have a generalization of the graph. Okay. How is the tangent related to the sine of the cosine? Does anybody remember from grade 11? Yeah, dude. Awesome. So the tangent curve is equal to the sine curve divided by the cosine curve, or the tangent is equal to the sine divided by the cosine. So we're going to use this information here, what we know about the sine curve and the cosine curve, to help me draw what the asymptotes are and what the zeros are. Okay? Because wherever the cosine is equal to 0, what's going to happen with the tangent graph? whenever the cosine is equal to 0, yeah? Yeah, there's going to be a vertical asymptote. So let's draw those guys in first. A vertical asymptote here, 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 and here. Okay, so the first thing we did is we drew in the vertical asymptote. Whenever sine is equal to 0, what's the value of the tangent going to be? Yep, 0. So wherever sine is 0, the tangent is 0. Now, if you ask to reproduce this on a test, this is all the information we can glean from the sine and cosine curve. But now we're going to use the calculators to help us graph the rest of it. And once we get what the rest of it looks like, then we'll know and we can just reproduce it. So again, just like we did the first time, is I just need an additional point. So somebody tell me what the tangent of pi over 4 is. And in this one, you have a tangent button in the calculator. So just hit tangent of pi over 4. And what value do you get? Yeah. On this side, I want to figure out what it's doing over here. So I'm going to take halfway between here, which is the negative pi over 4. So what's the tangent of negative pi over 4? Excellent, yes. Okay. And what do you think, Kyle, as you get closer and closer to the asymptote, what do you think is going to happen? Yeah, it's just going to, would you say it's going to keep happening? Yeah, and then where's the blue dot's going to go? Down or up, do you think? Right, exactly. So what's going to happen is it heads up to positive infinity, comes down, it goes through 1, goes through 0, goes through -1, and then heads down to negative 50. Doesn't look all whacked as that. I just can't really draw all that well on the smartboard. So this right here is the primary graph of the tangent curve. Okay, and you can see that half a pi on this side, half a pi on that side, together to make a full pi. So the period of the tangent curve is pi, not 2 pi. That's how it differs from the sine and cosine curve. But then the pattern continues on. So this is 1, this down here is -1, and then you just draw it. Let me try to do it better. And on this side, just draw that part. 1, -1. Like that. And then on this side. So that's the tangent. A lot of arrows on the end. So the domain is done the exact same way. So the domain of the tangent curve is x is an element of the real numbers, except where you can't find a value for tangent, which is the listing of the asymptotes. So negative and positive pi over 2, negative and positive 3 pi over 2. And our range, because the tangent curve heads all the way to positive infinity, comes all the way down, hits negative infinity, it's going to hit every single real number. So y is an element of the real numbers. So now that you know what the tangent curve looks like, on a test, if you're asked to reproduce it, you're really just using what you know about the sine curve and the cosine curve. The cosine curve tells you where to draw the asymptotes. The sine curve tells you where it's 0. Remember what it looks like, and you just draw. Rebecca, were you going to ask something? Yes.
I'm so confused as to why aren't they all according to the asymptotes that they're divided? Because it's like 1 over 0 is 0.
1 over 0 is undefined. Right, you can never divide anything in mathematics by 0. That's why you get an asymptote. But when sine is 0, that's 0, and you're dividing it by cosine, which isn't 0. So you're getting 0 divided by anything is always 0. That's why when sine is 0, it's 0. When cosine is 0, you can't do it, so that's where you're getting the asymptotes. Does that make sense? Okay. So then use what I've done with you so far, and see if you can draw the cotangent. Okay, and remember that the cotangent is the reciprocal of the tangent. So if the tangent sine of a cosine, then the cotangent is the cosine over the sine. We use that information to help you draw.